Well, and now here's the part you probably really want, the TI-84 shortcut. Now remember, when you're doing free response, go ahead and show the calculations. But yes, multiple choice, absolutely go to the shortcut. So you enter your data in a list by pressing Stat and Edit, unless you have the stats, and I'll get to that in a second. Put your data in list 1. You can change list, just remember where you put it. Press Stat and scroll to Test over here. And then you should select this T interval and press Enter. Then you'll get this input screen. Here you can choose to put in data or stats, and I'll show you, you can get examples where they just give you stats. And then for the list, select list 1 or wherever you put your data. Make sure your frequency is 1, unless you actually do have a frequency list for your data, in which case it might be in list 2. For the confidence level, enter the confidence level in decimal form. So you can see here, this is the output that I got after I put in my coffee data, and it shows the interval on top here, and my mean and my standard deviation and the sample size. So now I'm going to go ahead and do a interval for where I'm just given statistics. A sample of 50 randomly selected SAT math scores from Cedar Ridge had an average of 570 and a standard error of 85. Construct and interpret a 99% confidence interval for Cedar Ridge SAT math scores. So first of all, they want us to do a 99% confidence interval for the true average SAT math scores at Cedar Ridge. My plan is a 1 sample T interval for the mean. And is it random? It's given in the problem. 10%, we have over 2,700 students, I believe, so 50 is definitely fine. The large normal condition, don't know the distribution. I suspect it would be normal, but it doesn't matter because my sample size is greater than 30. It's 50, so this condition is met. Now let's go ahead and do the calculations. So I know, here's the information given to me. I went ahead and calculated the degrees of freedom, which is 49, not too hard to calculate. And I can calculate my standard error for the mean. And I can also do my critical value, inverse T. Since I want a 99% confidence interval, I subtract that, divide by 2, because that's a piece on both ends, and put in 49 for the degrees of freedom. And I get negative 2.680. So my confidence interval is my mean, or my point estimate, pretend that says 570, plus or minus 2.680 times my standard error. And if I go ahead and do that calculation, I get this value. If you did the shortcut on your calculator, you should get roughly the same. It might be a little bit different because of rounding right here and right there. Okay, so we are 99% confident that the true average SAT math score at Cedar Ridge is between 537.78 and 602.22. Now, another thing is determining sample size for a T interval. It's more complicated. We don't know the standard error without taking a sample. So oftentimes they'll need to provide us with an estimated standard deviation first. Or you could do a pilot, take a preliminary sample and use that standard error. But since we don't normally get to do pilots in class, you'll probably get an estimated value. Now, we don't know the critical value. Since we don't know the sample size, we have to find degrees of freedom. So first we're going to use the plain old normal distribution. And what you can do, especially if it's a small sample size, we can recalculate using the t value from the resulting sample size that we get. So I'll show you that on this next example. We want to create an interval for the average income for a Cedar Ridge family with a margin of error of $1,000 with a 90% confidence level. We believe the standard deviation in incomes is about $20,000. What sample size should we use? All right. So here's our initial values that we know. I'm going to use this formula, which is margin of error is critical value times the standard error. So I need to find my critical value. Again, I'm using Z because I don't know sample size. And it's negative 1.645. I substitute into my formula. And I'm just going to move the 1,000 here. It's sort of like a cross multiply. and I get this. So square root of n is 32.9, so n is 32.9 squared. That gives me this number, and I round up to 1083. Now let's go ahead and recalculate using this as our initial value. Okay, so now we have an initial value of 1083. And now we are going to do it again with the margin of error. This time I'm calculating a t critical value. And I put that 1082 because that's the degrees of freedom. And I get negative 1.646, which is almost the same as what I had before. And if I go ahead and solve for n, I get a sample size of 1084. So it only went up by 1. Why did it only go up by 1? Well, because this is a pretty large sample size. This is a pretty high degree of freedom. So it's kind of similar to the normal distribution. Now, if I had gotten a sample size of 40 or 100, this actually would be significantly different. Anyway, so that's how you can calculate sample size when you have estimated standard deviation.